Working on the next part of the series. There's probably going to be a few more diving into specific AI architecture and methodology that you guys haven't gotten to yet. So we'll see when you do, but this is what's coming. So you can look up, just search with my name and the essay title. This one is called The Approaching Paradigm. And I'm just going to go over it instead of reading through the whole essay. So the key concept here is you can build an AI that will emulate a piece of software. You guys have already started doing this kind of funky, kludgy, but there's going to be a systematic way to do it where you actually have two AIs. One of them has already been trained on how to input values into a piece of code to test the output so that it's the tester bot. It's going to build up an inventory of test cases. We put in this set of inputs, we got this particular output. This is not for something like a Paint program or an Excel page because those have an exploding possibility space of inputs. There's no way to predict or plan that. But for lots of other kinds of software, there's a finite but very large input space, and you can't hold the entire input-output lookup table. But you can test for the boundaries of those outputs. The particular outputs from a space of inputs. You've got your whole space of all the inputs you could put in, and the outputs that you're going to get are going to be blocky. There's a region that all those inputs produce the same output, and then another region where all the inputs in that region produce the same output. So whenever the outputs are blocky like that, you can test the boundaries of that space. And so that AI is going to be testing the input-output space boundaries for various types of software. And then once it's got those test cases, it uses those bounded test cases to train the second AI. So this first one is generalized for testing all kinds of different software to build up that inventory of data. And then for a particular piece of software, once you've found its input-output bounds, you're going to take that data set for that one piece of software and feed it to this other AI. And so this AI learns to emulate the software as an input-output lookup table. You just plug the inputs into this AI, and it's going to spit out the outputs. And that's only for that one piece of software. But that's a lot faster than actually running the code. And more important, if you find a bug or a zero-day hack in the software, you don't have to find some way to rewrite the code so that it's now safe. You never have to follow the constraints of the language it was written in. You can just change the output value to what you wanted it to be and retrain the AI. So if you originally wrote code in JavaScript and then you want it to fix something that you can't fix within JavaScript, and you're like, well, let's write it in Rust. No, just change the outputs that were a problem and retrain it. That's it. So that makes this piece of code for that piece of software, it's basically like the Borg from Star Trek. You can only glitch it once before it updates, retrains, and now that glitch won't work. And more importantly, once you have this AI that's trained only to emulate that one piece of software, you can throw the original code base away. Full delete. No record of that code base anywhere on Earth. You're just using the AI. So we'll get there. I'll see how long it takes.